Have you ever gotten to a point where you're working on a project and you're stuck and you don't know what else to do? And so you just stare at it, expecting the solution to just show itself, but it never does? My name's Callie, I'm the OKS engineer, and I once again severely underestimated the amount of effort it would take to get this layup set up. Before we jump into this, I'm going to be laying up a pretty complicated integrated flange into this layup, and all of that was covered in last week's video. I'll go ahead and link it up here. Check that video out first. It'll make this video make a lot more sense, and then come back and finish the rest of this one. All right, so I'm ready to start putting the first layer of carbon in. Now, when I bolt this all together, and it's going to be in a weird orientation, there's going to be some areas in the mold where basically the carbon's going to be overhanging slightly. And so because of that, I need to make sure that the carbon stays secured to the mold. And so I'm going to be using spray adhesive to do that. Now, this may not be the best way to do it, but this is how I'm going to do it. The best adhesive that you can get is by Fiberglass. It's 1601-A. This is specifically designed for resin infusion. The spray adhesive will dissolve and then actually become part of the resin, and that will create a really consistent, nice, I guess, crystallization or curing of the epoxy resin that you're using. So this you can use as much as you want, and it's really good, and it won't cause any bad effects to your part. Now, 3M has a similar one called Super 71. That's also good for resin infusion, but you also want to make sure it's good with the resins that you're using and the epoxy that you're using. This is 3M Super 77. This does not share those characteristics. This stays in the mold or in the actual part. Not ideal, but this stuff is blue when you spray it on, and the Super 77 is basically clear. So I'm going to use the clear on the mold surface because I don't want any of that blue dye to show up on the outside of my part. And I'm only going to use this on the outside just to secure that outer layer so I get that clear basically adhesion, and then I'll use the correct stuff to go between layers of carbon. So once again, probably not the best, but this is what I'm going to do. The seat mold that I did, I used exclusively 77, and it worked out just fine. So that's what we're going with. All right, so let's get into the materials that I'll be using for this layup. The first layer that I'm going to be putting down is a stabilized 3K 2x2 twill. The stabilized means that it's going to hold these fibers together. You would typically use this in something that's going to be a cosmetic part and you want it to look pretty, and that outer layer, you want all those fibers to be aligned. That twill is going to hold that together. The disadvantage though is you lose a little bit of the conformability of the material because that twill is basically holding everything stationary. And I'll demonstrate that more here in a second. I do want to take a quick second though to note just how great this packaging is. Each roll is individually sealed and wrapped to make sure that they're clean. They're also saran wrapped on the inside to make sure that all your carbon stays nice and neat and doesn't have any pools, and they are wrapped around, I believe, like a cardboard tube. So extra effort there to make sure that all their customers receive good carbon from the start. I've been disappointed in the past with some other suppliers. You get a roll and it's basically all pulled all over the place from the start. So huge props once again to Fiberglass. Thank you so much. Great job on the quality control. All right, the first layer of carbon is officially down. It went actually pretty okay. No big surprises. I did have to cut a relief kind of over here just because it started to bunch up and I didn't want it to basically buckle. The worst part is definitely down in that area. It's still not even that bad. Luckily though, that is completely under the helicopter and you'll likely never see it, and it'll probably be covered up with paint. So really not a big deal. Everywhere else was perfect. The most important part about this first layer is getting these seam lines where I need them to be. Remember, those will be the cutting guide
for where I'm going to cut from the outside of the part.
I even think I'm going to get a really nice seam between these two pieces. I got the weaves to line up, so that might end up actually looking pretty sweet as well. Overall, pretty stoked. Next step is to continue bulking the main area, which is going to be the removable portion of the cowling. That gets bulked up first, and then we'll start working on the lap joints and getting that set up.
The second layer and third layer I'm going to be using is a 6K 2x2. I'm using the 6K because it's basically half the effort. I can put one layer of 6K down instead of 2 layers of 3K, and I can just build bulk faster. So that's why I'll be using 6K for this layup. This 6K is unstabilized, and to demonstrate that, so here is a stabilized 2x2 3K, and you can pull on this and stretch it, and it basically returns the material back to its original size. It also prevents the edges from pulling out, and it keeps all those fibers nice and tight. That's why it's going to keep it pretty. Now the unstabilized traditional 6K, if I pull on this, it's going to deform. It'll deform further, but it'll stay deformed. And if you get to a point where you're pulling on fibers and you get all these strings, all those strings are going to get into your part, and it's going to make things a disaster. The advantage though is it will conform to a much tighter curve, and it'll hold those conformities better. So it really just depends on what you're doing. There's no point in doing a stabilized weave, in my opinion, after the first layer, but I'm new to this, so what do I know?
The next step is to go back and fill in just the edges where those lap joints will be. That'll stiffen up the edge of this cowling and just make it a little bit stronger for those repeated uses when we take those bolts in and out. All right, the last bulk piece of carbon went into the main part of the cowling. This side of the mold does require that I go flush cut all the carbon to the parting line of the mold, so I'm gonna get that done now, and then we'll get on to the more interesting part of this layup. All right, we are ready to make that lap joint joggle. I don't know what you want to call it, but basically the flange that we're going to incorporate into this layup for this build. So the way this is going to work, now that I've got the bulk down for the main part of the cowling, that'll be the part that's going to be removed or removable. I added additional bulk in this area, once again, just to give me a thicker flange to deal with, so it's stronger for those bolts to go through. Now I'm going to lay in a layer of Kevlar. This Kevlar's only purpose is to tell me when I've cut basically deep enough to separate the main cowling from the flange. So it's not actually giving me any structural support. It's not doing anything structurally to the layup. It's purely there so that as I'm cutting from the other side once I hit it. From what I'm told, you hit once you hit Kevlar, it's a disaster, so it should be very telling as soon as I hit it. And that will tell me to stop cutting. Now, in order to make the flange now, and make sure that it separates from the rest of this, I'm gonna lay in a layer of peel ply. And so this peel ply will inhibit the epoxy from bonding to the two layers. So this is going to be a barrier for adhesion, basically. And so that will tell me, or that will separate the flange side from the cowling side. And then on top of that, I'll lay my carbon over the top, but I'll be super careful not to extend past this peel ply. And so in theory, when it's all done, I cut from the other side, I hit the Kevlar is underneath the peel ply will give me the separation between the front portion of the cowling or the flange and then the rear portion of the cowling, which needs to separate, and then those two pieces should break apart. That's the theory anyways. We'll see if it works out. All right, this side of the layup is basically done. Couple things to note. So I got Kevlar on the entire edge where the lap joint will be. There's Kevlar hidden obviously underneath this part, which has the additional carbon from the flange already laid over the top. The reason that it's not laid over the top up here, that's because the carbon will actually come from the other side of the mold. So I'll leave those edges long and they'll overlap here. A lesson learned for me again is I cut this peel ply a little short. I'm real worried about being able to get that up and then getting a parting tool or something underneath there. So I'll probably leave that a little longer on the next mold. And then I'm also gonna run the peel ply that will cover the bulk of this area underneath this peel ply. So when I peel the bulk of that up, the goal is it'll actually give me something to start with, and hopefully it'll make things easier to get that off. Other than that, pretty straightforward. Oh, one more thing. I did the flanges on the parting line got wrecked with just carbon fibers and all sorts of stuff and spray adhesive. So I'm going to go back and clean that up real good, and I'm probably going to mask off the other mold with blue tape anywhere that parting light is, just to make sure that it's really clean. So let's get to the second half. The next layer we're going to put down over all of this is an Econo Stitch peel ply. This is to prevent all your carbon layers underneath from sticking to the vacuum bag, and it's essential for any layup. The first layer of 3K is down. It went down really smoothly. The only real difference between this side and the other side is the excess material that I have over the edges. That's there so I can create that overlap into the other side of the mold, and that will be the flange portion of this half of the cowling. The next thing I need to do is just bulk up the main area, the removable area, with the 6K. So we'll get that in, and then we will lay up the flange. The next step is to lay in 2 additional strips of 6K for bulking. So I'll do that around this edge, and then we'll finally follow it up with one last layer of 6K over the entire cowling side to close out the cowling side of this layup. The next step is to lay down our Kevlar layer for our depth cut finder, and then on top of that our peel ply to make sure that the two pieces separate. And now we'll close this section out with another layer of 6K, a strip of 6K for bulking for that flange, and then the final cover layer of 6K over the top of this section.
And all the carbon fiber is now sealed off with a single layer of peel ply. I did the same on this side as I did on the other, where this piece of peel ply goes underneath this joint to help with separation. And I also did that under this joint as well. Have you ever gotten to a point where you're working on a project and you're stuck and you don't know what else to do? And so you just stare at it, expecting the solution to just show itself, but it never does? That's kind of where I'm at. I don't know if I should try and lay down some flow media in each half. The problem with flow media is it doesn't stay down for anything, so it's really annoying to work with. And I'm also wondering, should I start making my bag? And maybe I make 2 halves of my bag that I then seal together with tacky tape. And then at what point do I throw these things together? Because once it's together, I mean, working on it on the inside is going to be a nightmare. And so I don't know what to do. I think maybe the flow media would be easier with the molds together. Pretty sure the vacuum bag is going to be a disaster anyway I cut it. And I don't know. I'm just going to stare at it a little while longer. This is the green HDPE infusion flow media. This is just a pretty standard resin infusion flow media, and without this you won't actually get the resin flow to go throughout your part. I use the templates for the carbon to rough cut the flow media, and it's not quite big enough and needs a splice. Now, what I used the last time to make this splice was some duct tape, and that worked okay, but it didn't hold very well and it was kind of annoying to deal with. I've also heard that the tape adhesive may actually affect the layup. So I then started doing some research, and ChatGPT told me that hot glue is a good idea. So that's what we're gonna try. In this layup, I have a section of vacuum bag laying underneath the flow media. I'm gonna put a couple dots of hot glue across that seam, and then I'm going to put a little postage stamp size piece of the vacuum bag over the top of that to create a sandwich and make sure that there's no sharp spots or anything, and I'm hoping that that will hold the 2 pieces together fairly well. That ideally will mean that once I put it into the mold, it'll be easier to work with and I don't have to worry about the 2 pieces coming apart. Well, I've done just about everything possible to delay putting these 2 molds together, mainly because, one, they're huge. I'm by myself. I don't really know how I'm going to do it, and I think it's going to be pretty sketch. And once it's together, it's not coming back apart until a piece of carbon comes out of this thing. So I don't know. I'm just apprehensive about it all. But there's no better time than the present. We are going to set this thing up. You can watch the sketchiness ensue. And hopefully I have good news at the end of this. So once I got the 2 halves together, it got a little hectic and I didn't exactly stop and record everything, but there should be a decent amount of footage that I can at least explain what I did. So I have to work through basically this little itty bitty opening and reach down, which is a nightmare, to get the rest of this layup done. So basically what I had to do was, once it was all together, the seam line, which you can see down in the middle, that all that layup had to be situated, and the flange needed to be laid over in the correct, I guess, sequence. So that got all done. I had to make sure that the Kevlar down there was placed in the right spot. And then finally the flange where the tail boom opening is had to all get laid in as one piece, because that can't have any seams in it, and that's going to be one solid layup when it's done. So it'll be a separate part after this is all finished. Once that was all done, then obviously covering it all up with some peel ply and getting it all ready to go. The next thing that I'm going to do, hopefully tonight, I'm worried about leaving all this carbon standing up and slightly overhanged. I don't want it to fall off the mold. God, that'd be a disaster. So I'm going to try and get the flow media in here. I've already made the bag, so I'm going to try and get the bag in here and at least get an initial pull of vacuum. That way it holds everything against the mold and will hopefully prevent it from falling down. The rest of this, I guess I didn't mention, all the bolts are now in for the entire border, the entire parting line of the two molds. And basically we're go time. When I was originally planning this layup, I planned to do a single layer of Kevlar on the internal surface of the part. And there's a couple reasons for that. One, it's basically required for aviation parts, certified parts, because it acts as a kind of a blanket to prevent the carbon, in the event something bad happens, from shattering and basically leaving the aircraft. This will hold it all together with its Kevlar fibers. It's also a bear to work with, and I haven't mentioned it yet, but the flanges that I'm building into this mold currently, or this part currently, those are the flanges to affix the cowling to the aircraft. They are not the access panels that I'm going to be creating later. Now, if I put this Kevlar down where those access panels are going and I have to cut this part later, it's going to be a disaster. So I'm going to forego on the Kevlar for now. I'm probably going to make those access panels in the future, and then I'll probably do one more local layup to fill in the interior of that cowling with Kevlar. That'll do prevent things from scattering in the event something happens, and it also adds, funny enough, an insulative barrier because carbon is electrically conductive. So it'll help with any of those issues as well. And as a quick demonstration as to how miserable Kevlar is to work with, fiberglass sells Kevlar specific scissors. And when I first looked at it, I thought it was a joke, and I was like, I'm sure I can sharpen a pair of scissors to cut Kevlar. Well, this is their Kevlar scissor, which is specifically designed for cutting Kevlar. And then this is my brand new sharpened, literally today, super sharp set of shears. And it doesn't even come close to cutting these fibers. I've done everything I can with these standard scissors to try and make it work, and I just can't. It just turns it into a hot mess. I can then come back with these Kevlar scissors and it cuts through it like butter. So strongly suggest, if you're going to use Kevlar, get a dedicated Kevlar scissor from fiberglass. They're great, and it cuts this stuff like cake. So huge win for ChatGPT. That's where I got this hot glue idea. I was brainstorming with ChatGPT to figure out a better way than duct tape to secure the flow media, and this stuff works awesome. If you're not using hot glue to secure your flow media to your mold, you're not doing it right. I mean, it is great. Half of this flow media is in, it's all secure, it's not going anywhere, it's not going to move. I mean, couldn't ask for something better. Awesome. Now, once again, for my layup specifically, I'm doing one layer of 3K. I'm going to do 2 layers of 6K. The peel ply will go on top. It's important to note that your peel ply needs to cover everything completely. Once again, if it isn't, it will stick to your bag, and demolding it will be a nightmare. After that is your flow media, and then you obviously need something to get your resin into your part. For this, I'm going to be using some spiral tubing. This is 1/4 inch spiral tubing. It goes to a 1/4 inch T, and then that T goes to 1/4 inch just standard tubing that goes out to my buckets. That gets laid on top of your flow media. If you lay it outside of your flow media, the flow from there into the media will take forever and it will slow your infusion down, which is not ideal. So make sure that your infusion lines are definitely over the top. Now on the other side, the vacuum line, you can use much the same spiral tubing to create that cavity for the vacuum to happen, T-line, whatever you want. But in that case, you can actually place it strategically off of your flow media, and it's called a resin break. So the resin will significantly slow down once it reaches the edge of the flow media, and you do that at the edge of your part just to prevent like a short circuit of the resin being able to go directly into your vacuum line and sucking excess resin into your hopefully catch can that you have before your vacuum. So in order for your feed lines to get resin into the part, I, on my last infusion, used spiral tubing. The difference though is in that layup, I was able to run my spiral tubing around the perimeter of the mold and it wasn't directly on the actual part. If it is on the part, there's a good chance that you'll get print through, or basically a blemish. You'll be able to see where that line was running from the outside of your part. And the only way to infuse this part, from what I figured out, is to actually have your feed lines laying directly on the actual carbon. So I made a late game-changing decision and I made an order through Fiberglass yesterday at 2 o'clock, and sure enough, if you get your order in before 2:30, it will go out that same day. And so here is the next day at noon, basically, the parts that I was waiting for. This stuff is called Infusion Filter Jacket. It's basically a flow media inside kind of a little filter. You can lay this directly onto your laminate and don't have to worry about print through. So that's what I'm going to be using to distribute the resin through this mold and this part. More so though, huge shout out to Fiberglass. If you get your order in before 2:30, they will ship that same day. And for me, them being in Columbus, that's a next day shipment right to my door. Okay, I think we are ready to vacuum bag this thing. So let me go over how I'm going to infuse this thing. There is a spiral tube that goes around the entire top. That's going to be my vacuum. And so everything's going to suck to there. I do have 3 fittings. There's a T-fitting down here, and then there's a T-fitting on either side. That is basically just to distribute the vacuum and make sure that that it's clean all the way around, so that'll all get tied into one and then go back to the vacuum. For the resin side of things, the big difference, well, I'm doing something a little unique. I'm gonna have, you see at the very, very bottom, there's 3 legs coming out. I was gonna do 4, but it just didn't work out how I thought it needed to be, so I'm down to 3. I'm actually going to feed 4 lines though. I'm going to feed 1 line into the bottom of this one, 1 line into the bottom of that one, and then I'm going to feed 2 lines into the bottom of the center one because it has this branch up here and there's a lot more volume, so I want it to flow better that way. So I have them coming up towards the top. The main reason that I wanted to have a line in the middle down there is because if I branch it in the Y, the vacuum's out here, and I was worried that the center section was going to be lean, and so I really wanted something to be down that center section, hence the center section and the tree. Now there's one more, and I'm going to have to walk around here to show you guys, but I ran a loop of spiral tubing down in that tail boom opening. That's another infusion point. So I'm going to have a 5th line going into that tail boom hole because once again it was sunk down in there and I didn't think I was going to be able to get the resin to suck backwards, backflow down into there. So that's also going to feed. You might think I'm crazy, but there's also 2 more infusion points, one at the tip of each of those front protrusions. And so it's going to flow
resin down this way and then out the vacuums. I'm going to get resin from the very, very center tip down there. It's going to come up these trees and flow up to the vacuum tubes. And then the last one is in that boom. So the whole boom is going to get infused with resin, and it's going to come up and help infuse this side. I figured you can't have too much infusion. The worst case scenario is you end up not putting enough into your part and you end up with a lean part, and I really don't want that to happen. So that's what we're going with. 1, 2, 3, 4, 5, 6, 7 infusion points. This thing should take about 1.5 gallons of resin. So, God bless. For the vacuum bag, I'm using Stretchlon 800. This stuff is actually really nice. It stretches a lot before it actually tears. That's especially good for getting into like valleys and cracks where you might have a bridge. It'll actually just suck down and maintain the seal rather than puncturing your bag and then you having to go redo the entire thing. It's currently only done on the inside. If you remember from the last video, I was going to experiment with putting a seal between the multi-piece molds, and I fully did not think it was going to work at all. And going into this, I figured I was going to have to envelope bag this entire thing. To my surprise, it held vacuum for 8 hours and only lost 1 inch of mercury. So I think that seal worked, and I'm not actually going to envelope bag this thing, and we're going to leave it as is. It wasn't too horrible of a bag, to be honest, but I mean, the geometry isn't too bad. It's pretty straightforward, but shocked to see that it actually held through those seals and the flanges, and stoked that I don't have to put any more effort into this. I know I told you last week that we'd probably have an infusion and a part this week, but I severely underestimated the amount of effort it was going to take to get this layup done. This is seriously one of the most tedious and longest layups I could ever imagine doing, and if this doesn't turn out perfect the first try, oh my god, I'm going to struggle to have to go back and do this again just for the sheer amount of effort it took to get it here. Thank you, Fiberglass, for your continued support. All the materials that I've used for this layup can be found in the video description. Come back next week. I promise we'll have a part, good or bad, it'll be here. As always, go build something cool, never stop learning, and we'll see you on the next one.